are going to discuss mathematics for CSE stream, super important questions. These are the 5 topics which are really important in this module and are the most repeated ones in the VTU examination. So the first question is finding angle between the curves. So let's get into it. The first question here is find the angle between the curves r equal to a log theta, r equal to theta divided by log theta. Here we have the formula that we are going to use u into v. We don't need to remember any formula. All the formulas are provided in VTU handbook, and this formula is in VTU handbook page number 1. I will provide the link in the description for VTU handbook. You can access it. So writing down both the equations here, r equal to a log theta, r equal to a divided by log theta. Here, looking into the equation 1 first. Here we are going to differentiate with respect to theta. Since r is taken as variable, it will be dr by d theta equal to, since a is constant, it will be as it is log theta. Differentiation of log theta with respect to theta is 1 by theta. Here we are multiplying 1 by r on both sides. Multiplying 1 by r on both sides, it is 1 by r dr by d theta. Here, since we know, here look here, r we know that r is r equal to a log theta. So we are plotting it same here. We're gonna plot the same here. We will get a divided by a log theta. So a get cancels, and we're gonna reciprocal both the equation r into d theta by dr equal to theta log theta. So we know that r d theta by dr equal to tan phi. Okay, that's clear. So here we get the equation, and we're gonna look into the another part. So here r equal to a log theta. Here we are gonna send the log theta into left hand side. It will be r log theta equal to a. Here to differentiate, we need to take uv. To take uv, there is a formula u into v. So this is a formula which is provided in page number 1. It follows ILATE precedence. Precedence means priority. So which will be taken, which variable or function will be taken as u first. So if it is inverse trigonometry, it will be taken as first. So here logarithmic function. So we have logarithmic function log theta. So u will be taken as log theta and v will be r is a algebraic function. So on differentiating this equation with respect to theta, according to this formula, we are gonna get log theta as u is taken as a log theta, same as it is. V is taken as r dr by d theta plus v, which is r. Differentiation of log theta equal to 1 by 5 equal to 0. Okay, since a is a constant, if we differentiate, it becomes 0. Okay, now we are sending r by theta into right side, it becomes negative. Later we are rearranging the equation, it becomes 1 by r dr by d theta equal to 1 by minus theta log theta. So here what we are doing is, we are sending the log into right hand side and taking the r into left hand side, because we need to solve, we need to get tan phi 2. Okay, right. So on reciprocaling this equation, see, look here, on reciprocaling this equation, we are going to get r d theta by dr equal to minus theta log theta. So we know that here, we know that r dr by d theta equal to tan phi equal to, it is tan phi. Okay, further we have got tan phi 1 and tan phi 2. So here, moving into the next part, to further simplify, we need to take tan phi minus phi 2. We need to subtract these both. So to subtract this both, there is a formula. Tan a minus b equal to tan a minus tan b divided by 1 plus tan a tan b. We don't need to remember any of the formula. All the formulas are provided in the handbook. So this formula is provided in the page number 4 of the VTU handbook, which will be provided to you during the examination. So just here there is a change. You need to take phi 1 minus phi 2, right? Just here a minus b is given. Wherever a is there, you replace it with phi 1, and wherever b is there, you replace it with phi 2. On replacing, we get this equation. Now plot the values. Tan phi 1, it is here, theta log theta minus here tan 2 value, tan phi 2 value, plot this value. On plotting all the equations, we get this value for tan phi 5 minus 5 1. Okay. Further, there's nothing left in the question. Just simplification is left. Minus into minus is plus. So minus into minus is plus, and 1 is same as is it. Theta into theta is theta square. Log theta into log theta is log theta whole square. Here we need to take plus into minus is minus. Here we need to, oh, it is minus minus. It is minus. Okay. Here it is minus, and later nothing. Theta log theta plus theta log theta. It will be nothing 2 theta log theta. Here the plus is not getting minus is not getting added, so we are hiding it down. Okay, from equation 1 and 2, see these two equations, r equal to, right? Then we can write this a log theta equal to a divided by log theta, right? So we are doing the same here. We are going to write it a log theta equal to a divided by log theta. So a get cancels. We are multiplying the log theta into left hand side. We get log theta square equal to 1. Okay. Here it is a logarithmic property. Log e equal to theta. It becomes log e theta equal to 1. So we can write theta equal to e raised to 1, which is nothing but theta equal to e. Now we got this right, tan phi 1 minus phi 2. Here wherever theta is there, just replace it with e. When we replace, we're gonna get 2e into 1 divided by 1 minus e raised to 1. This equation. See, look into this equation. 2e into 1 will be 2e. 1 square is 1, and e raised to 2 into 1 is e raised to 2. So there is nothing left now. Phi 1 minus phi 2. We are sending tan here. If we send this tan into the right hand side, it becomes inverse here. So we are writing inverse, tan inverse. Okay, tan inverse, and the equation remains the same. So the final equation we are getting here is 2 tan inverse e. Okay. So moving to the next question, it is the find the radius of the curvature of the curve y equal to x cube into x minus a at the point a comma 0. So here a we are taking it as x and y we are taking it as 0. So here is the given equation. We are simplifying it. On simplification we get x raised to 4 minus ax square. Now differentiate this equation with respect to x. Here dy by dx we are taking it as y1, and x raised to 4 differentiation is 4x cube, and a is constant. X cube differentiation is 3x square. So moving further, now look at here the point a comma 0. At a comma 0 we need to find y1 at a comma 0. So a is taken as x and 0 is taken as y. So take here a, plot the values. We are going to get 4a cube minus 3a cube, which is nothing but y1 equal to a cube. Okay, now take the y1 equation again. Now take the y1 equation again and differentiate this with respect to x. Now we're gonna get here d square y dy by dy square. On double integration we are taking it as y2. Okay, 4 as it is x cube, 3x square, 3 as it is 3a as it is x square, differentiation is 2x. So further on classification we have 2x square minus 6x. Same as we have done in y2. Now we need to calculate in at a equal a comma 0. So we are calculating here as it is 2a square minus 6a into a, 2a square minus 6a, which is 6a square. Okay, now last step is remaining, which we need to plot by Pledel equation. So you don't need to remember, as I told, any formulas. Here we have pedal equation in cartilage form. This is present in video handbook page number 7. No need to remember anything. Now just plot the values. Plot the y1, y2 and y1 values we got before. Okay, just plot the values. Here y1 and y2 we are plotting the values. Here y2 is 6a cube as it is we are plotting here, and y1 value we got a cube, right? Plot here and just leave it, finish. This sum is very easy, don't leave it blank. Okay, so moving out to the next question, find the radius of curvature of the curve x raised to n equal to a raised to n cos nx. Here there is a problem, they have not given the point, so there is a different approach to approach this problem. Okay, so write down the equation. Different, now write down the given equation. Okay, write down the given equation and differentiate with respect to theta. We know x raised to n is common for x raised to n. We differentiate like n x raised to n minus 1. Same, we are taking it here. If you are not if you are not getting it, you can refer VTU handbook. Here the formula is given there. So dr since r is a variable, we need to take dr by d theta, and an is constant. We are keeping it as it is. Cos n cos n theta. It is differentiation is minus sin n theta and n. Okay. Now moving on. Moving on further, classification, we get r raised to n divided by r dr by d theta. Here r raised to n we are taking differently and we are sending the minus 1 downward. Okay. Now on classification, we get this, and we are sending the rn to the right hand side denominator for a classification. As we know, rn equal r raised to n equal to a raised to n cos n theta. So we are plotting the value here. See, you can look here. We are plotting this value here. Okay, we are plotting the value. Then we are getting a raised to n common and cancel it out. And we know that 1 by r dot dr by theta is nothing but cot pi equal to. So sin n theta divided by cos n theta is tan n theta. So we get this equation. Mark this equation as equation 2. And we know that pedal equation. This pedal equation is also there in VTU handbook, which is in page number 6. Don't remember any formulas. Okay, just write down this equation, and 1 plus cot square phi can be written as 1 plus tan square n theta. Okay, so here we have got it right. It can be written because here we have got it in the equation. Okay, and now the next step is 1 plus tan square theta is sec square theta. Okay, we are writing is same here, and now we are multiplying one secant square n theta can be written as 1 by cos square n theta. We are doing the same here, and we are taking the values and rearranging the equation here. Later we are reciprocaling the equation, which will be equal to p square equal to r square cos square n theta, p equal to r cos n theta. Okay, this is done, and we are removing the squares here. On removing the squares, we get remainder p equal to r cos n theta, and we know that cos n theta is nothing but r raised to n divided by an, as we got in the first equation. So here we are sending an with pn, a raised to n into p equal to r n plus 1. Okay, here these two get added as the properties. Now we need to differentiate with respect to p. Okay, since an is a constant, it will be same. P different, dp by dp will be 1. Okay, r raised to n, we are taking r raised to n, n plus 1, this is the x raised to n, same as x raised to n. Okay, n plus 1 r n plus 1 minus 1 will get cancelled, so we are getting r raised to n. Okay, here, and the dr, since r is a variable, so we are taking dr by dp. Okay, now rearranging the equation, we get r raised to n dr by dp equal to an divided by n plus 1. Okay, now we are taking this extra r for our simplification. Then we will get the answer like r dr by dp equal to a raised to n divided by n plus 1 into 1 by r n minus 1. So we know that r dr by dp is nothing but rho equal to a n divided by, as it is the equation how it is. So this part, see, this part is all, this part is full of constant, so we are ignoring it, and we need which row is which proportional to which equation. So row is directly inversely proportional to r raised to n minus 1. Okay, third question, it is we need to show two curves cut each other orthogonally. So the given curves are r equal to a into 1 plus cos theta and r equal to a into 1 minus cos theta. Just write down both the equations down here and differentiate with respect to theta. Now on differentiating with respect to theta, we get dr by d theta equal to a, as it is constant, and 1 is 0. When will be become 1 becomes 0, cos theta differentiation is minus sin theta, and the minus is we are keeping it here. Dr by d theta equal to a sin theta. So multiply 1 by r on both side, we get 1 by r into dr by d theta equal to a sin theta divided by r. Okay, this we are doing for simplification purpose. Okay, so we know that here, look here, r equal to a into 1 minus cos theta. So we are plotting the value here as it is same for simplification purpose. As we add, the equation becomes a sin theta divided by a into 1 minus cos theta. So a get cancels, and we know that sin theta equal to 2 sin theta by 2 cos theta by 2. Here the equation, here the formula is given, and this formula is also provided in VTU handbook in the second page number second. 1 minus cos theta is 2 sin square x by 2. Here same we are doing it here same. All this formula is provided in page number 3. Okay, moving further, 1 by r dr by d theta, we know that it is cot pi 1. Okay, cot phi equal to, on simplifying this, 2 gets cancelled, sin theta by 2, sin theta by 2 1 gets cancelled, we get cos theta by 2 divided by sin theta by 2, which is nothing but cot theta by 2. So on simplification we can see that cot phi 1 equal to cot theta by 2. Here we can write it as phi 1 equal to theta by 2. Coming to the second equation, similarly we need to differentiate with respect to theta. On differentiating, we get dr by d theta equal to b 0 minus sin theta. So differentiation and later simplification, we get minus b sin theta. Now here also we need to multiply both the sides with 1 by r, then we get 1 by r. So plot the r value. See, here it is the r value. Plot this value in here. Okay, on plotting we get b as common, and b get cancels. 1 by r into dr by d theta is nothing but cot phi 2, which is same here sin theta. We are applying the same formula for both, and we are getting cot phi equal to minus tan theta by 2. So here we got tan, but here we got cot, but here we are getting tan. So we know that minus tan theta by 2 is nothing but cot theta by 2 plus pi by 2. This is also provided in VTU handbooks page number second. Okay, or I guess in identities it is provided. So we can write phi 2 equal to theta by 2 plus pi by 2. Okay, now we got both the equations, phi 2 and phi 1. So just minus phi 2 phi 2 by phi 1. On minusing phi 2 by phi 1, we get, write the equations, pi by 2 plus theta by 2 minus theta by 2, plus theta by 2 and minus theta by 2 both get cancelled. So theta, phi minus phi 2 minus phi 1 equal to pi by 2. This modulus is important. You can either minus pi 1 minus phi 2. So the condition to for two curves to cut each other orthogonally is the difference between their phi's should be pi by 2. Okay. Going to the next question is finding the pedal equation of the given curve. So this question is repeated 2 to the 3 times, and also is been mentioned in the model question paper, which is 2a divided by r equal to 1 plus cos theta. Write down the equation as it is, and we need to differentiate this with respect to theta. So we are using u into v rule, which is provided in the handbook in page number 1. And as we discussed previously, it follows Eilert precedency or priority. So we are taking 1 plus cos theta, since it is a trigonometric function, we are taking it as u, and r, since it is algebraic, comes under algebraic function, we are taking it as v. So on applying u into v rule, we get 1 plus cos theta dr by d theta plus r, since r is v, it is taken as same here, and 0 minus sin theta equal to 0. 1 becomes 0. Okay, then rearranging the equation, later we are sending the 1 plus cos theta into right hand side, and r to the numerator of left hand side. We get 1 by r 1 by r dr by d theta equal to sin theta divided by 1 plus cos theta, which we know that 1 by r dr by d theta is nothing but cot pi, and as we discussed in previous problem, sin theta can also be written as 2 sin theta by 2 cos theta by 2. It is given in the handbook of video in page number 4. And 1 plus cos theta, as we discussed previously, it is the same, and it is also mentioned in the page number 4. you can plot the same, and on cancelling the equation, 2 and 2 get cancels, cos square theta, cos theta by 2 and cos theta by 2 one will cancel, so we are getting the equation sin theta by 2 divided by cos theta by 2, which is nothing but tan theta by 2. So cot phi equal to tan theta by 2, and we know that the pedal equation is also given in page number 6. So taking the pedal equation, 1 by p square equal to 1 by r square 1 plus cot square by 2. Here in the equation we got cot phi equal to tan phi by 2. Plotting the same, we get tan square theta by 2. So further we can write it as 1 plus tan square theta is nothing but secant square theta. Okay, we are plotting the same here, and on rearranging the equation we get 1 r square cos square theta by 2. Secant square theta can also be written as cos square theta. So on reciprocaling both the equation 1 by p square and the right hand side equation, we get p square equal to r square cos theta cos square theta by 2. So cos square theta by 2 can also be written as 1 plus cos theta divided by 2. It is also mentioned in VTU handbook in page number 4. So on simplifying the equation, we get p square equal to r square divided by 2 1 plus cos theta, or else you can stop here itself. Coming to the next problem, these are the prove that problems. So the question 5 is, with usual notations prove that tan phi equal to r into dr by d theta. So this can be proved. This is basically asked on part 1, and the second prove that problem is asked in part 2. So here we need to draw a triangle POX, and inner angle will be theta and the other angle will be phi, and the exterior angle will be psi. Okay, so we know that the sum of interior angles, which is theta and phi, equal to psi. So we are writing it down, psi equal to phi plus theta, and we are applying tan on both sides. Okay, I'm applying tan on both sides. So here we can see tan phi plus theta, which is in the form of tan a plus b. Taking it from the handbook page number 4, we are plotting the plotting phi plus theta as it is. Also we know that slope m equal to tan psi equal to dy by dx. Okay, so here we are taking x as r cos theta and y equal to r sin theta. Basically sin theta is always taken with y. Now we are differentiating equation 3 and equation 4 with respect to theta. So here we are using u into v rule. For u into v rule, as I have explained in the first problem, we use islet priority with the given equation, given formula in the handbook. On differentiating, we get dy by d theta equal to sin theta plus following. Now from equation 1, as we had here, slope equation tan psi equal to dy by dx. We are plotting the equation here. We are adding dy by d theta divided by dx by d theta. Further, we are adding this to, okay, we are adding this to, we get this equation. As we are getting this equation, we cannot simplify it further. To simplify it further, we are dividing this cos theta into dr by d theta for all the four parts. Four parts, which are the four parts? This, and this. We are dividing it all the four parts, and later we are simplifying it. Here dr by d theta gets cancelled. Here cos theta gets cancelled. Here cos theta and cos theta here also get cancelled. Dr by d theta, and we get the following equation: tan psi equal to tan theta plus r dr by d theta divided by 1 minus tan theta dr by d. Now we are comparing this with the before equation, as we have got in tan theta plus psi, or tan theta uh, plus phi. Okay, here we had the equation, this equation. I will show you, right, this equation which had this equation. We are comparing with this equation, and now we are comparing this and this equation. So tan theta equal to tan theta, good. Tan phi equal to dr by d theta. So this is the required solution. See, tan phi equal to dr by d theta. So we get the final solution. We, even if we reciprocal the tan phi equal to r into dr by theta, we're gonna get tan cot phi equal to 1 by r dr by d theta. Okay, this one was the first proof that, and we have another proof that problem with usual notation. So it is the pedal equation. 1 by p square equal to 1 by r square plus 1 by r4 dr by d theta whole square. So theoretical part you can write as you have written it down. Here the diagram changes a little bit. We have two triangles here. This one, the extra triangle is this one. You can look after this area we get the extra triangle. So there's nothing left. Same here, exterior angle psi disappears. We use phi and theta, interior angle, and extra triangle gets pi by 2. Okay, so in triangle OPM, as you can see OPM, we apply sine phi, which is OM by OP. We get P by R. We can, on simplifying, P equal to R sine phi. Okay, and square on both side, we get p square r square sine square phi, and reciprocal the equation we get the following equation: 1 by p square equal to 1 by r square cosecant square phi. Okay, further, on simplification, cosecant square phi equal is also can be written as 1 plus cot square phi. Okay, now we know that from the previous notation, this one, from previous notation, tan phi equal to r into dr by d theta, or cot phi equal to 1 by r dr by d theta. So we are comparing it, we are adding the cot phi value here, cot phi value, which is here, the cot square phi. We are adding this value. See, compare this now. Cot phi equal to 1 by r dr by d theta. Okay, so the equation remains the same, just here 1 plus, here we are adding 1 by r dr by d theta whole square, as cot square phi it was cot square phi, so we are adding the whole square. So 1 by, it becomes 1 by r square dr by d theta whole square. So the required equation is, now multiply with the exterior 1 by r square. We get 1 by r square plus 1 by r raised to 4, then the given equation. That's it. Hence both the problems are very important.